Hi, I'm Albert Ken Mata of ECE3A and I will be reporting about fatigue on material science. So, first I will define fatigue. What is fatigue? So, fatigue is defined as a process of progressive localized plastic deformation occurring in a material subjected to cyclic stresses and strains at high stress concentration locations that may culminate in cracks or complete fracture after a sufficient number of fluctuations. So, explaining further, fatigue is when you test the capability of a material to withstand a constant amount of stress for a period of time. So we can correlate this to a, um, for example, a body of a human. So our bodies can um, take a constant amount of stress before it leads to failure, or our body would lead to failure after like um, a lot of work, and it will cause stress leading to um, fatigue, which can um, fail our body in the process. So next is I will show a video of a tensile strength test. So before I discuss further about the fatigue, I will discuss briefly about tensile strength test because it will be vital to the discussion. So first, I will um, explain this test. So here is a material. It is a metal material, and it will be subjected to um, opposing stress directions, which is upward and downward. So it will test the um, strength of the material, overall strength, and I will explain the test after this um, video, the output of the test. So I will play the video first. So as you can see, force is being applied in a opposite direction, downward and upward force, and you will see the material starting to elongate, and there's a little microscopic fractures building up in the material's surface, and it will eventually lead to failure. So you can see, it led to failure after the amount of stress cannot be taken anymore by the material. So this is the process of the tensile test. It is the output curve of the test. So it is a stress strain plot, which you can see as the test is being conducted. The material is getting elongated from start to finish. So first is the um, it exponentially rises until its yield strength and ultimate strength. So after it reaches this point in the material, it will eventually lead to necking. So necking is the when the material starts parang breaking up. So this is the material. So that's getting tested earlier. And then there's force, upward force, and downward force. As the force is getting um, affecting the material, it leads to necking. Yan. The material is getting smaller in the like middlemost part of the material. So and it will eventually lead to fracture. Yung nabali na yung material sa gitna. So, why do we need to learn the tensile test first? So, the fatigue test will be same. We'll put stress in opposite ways of the material, but only until halfway through the here, halfway here. So we will do that over and over again for like several hundreds, thousand, or million of times until it leads to fracture. So this is the diagram of a um, determining the fatigue of a material. So it is a stress and time plot. So in this example, um, stress is being applied to the material only halfway through the tensile strength test kasi before ganyan yung itsura nung um, tensile test curve, but we're only putting stress until here, and we're putting this small amount of stress again and again until the material leads to fracture or failure. So it will determine how much stress a material um, can withstand. So next, another plot, a typical fatigue curve. So it is a applied stress and number of cycles plot. So what this indicates is that um, if you apply a greater amount of stress in determining fatigue of a material, it will reach um, failure faster when rather when you put a smaller amount of stress in a material. So this means if you apply a larger amount of stress, it will lead to fracture or failure faster than when you um, put a lesser amount of stress. It will take more number of cycles when the applied stress is smaller, as you can see here. When the applied stress is larger, the number of cycles is lower. When the applied stress is lower, the number of cycles is higher. So next, lastly is the repeated stress and localized deformation. So here is the what I've told earlier, the necking of the material in the middle part here. This necking will eventually lead to small amount of fractures in the material like this, and these fractures will um, amplify or shorten the amount of time it needs to failure. So if you have these small fractures in your material will um, go to fracture even faster. So that what's this mean. So yun lang. Peace out.